Morning, everyone. Hope you're doing all right this morning. It's our last day of class. And I bet if we were in a classroom right now, you'd be cheering. That's good. It's a beautiful day here, as you can see at the beach. Make sure you go to the beach before the summer's over. It could be another fall like last time. So we're not sure what's going to go happen yet. On campus, we're planning on teaching in person, but who the heck knows? So try to enjoy your summer when you have it, as you have a chance. Anyway, as you know, we have our final this weekend. It will be available to you starting midnight tonight. And it should be very straightforward for you. Let's go ahead and post up the information on that. And then we'll stop and see if there's any questions. Oops. All right. Again, I think it will be about 60 questions, not cumulative. All the lecture material will be covered since the midterm, including everything today. All the discussion material, and I've confirmed now with Dylan that all this stuff is on touch and illusions, Helen Keller video, facial attractiveness, multisensory attractiveness, synesthesia. All that stuff will be covered on the final. All the book materials starting with chapter 6 onward through the epilogue. And I should mention, I don't know how much of a chance I'm going to have today to get into the very last chapter on multisensory perception. This happens a lot in the summer where I'm not able to cover everything. So make sure you read that. Certainly, as always, the test will emphasize what I am able to cover in lecture, but there will be a few questions that are derived from that chapter, probably 2 or so, that I didn't have a chance to cover. So make sure you do go through that chapter carefully. It is open book, as you know, but you'll be taking this on your own. It's important that you not be taking it with anybody else, and you have to finish it within the 80-minute period. And please make sure that that you're ready to take the entire exam. There is no stopping. Once the clock starts for that 80-minute period, it will continue either until it's over, until you shut down the exam. So it's important you take it in one sitting. Okay, I don't think there's anything else I need to tell you, but I would not be surprised if there's a few questions. So let's go ahead and stop the sharing of the slide and see if there are any, and feel free either to speak up, or you can put your question in the chat. I'll give you a couple of seconds to get your thoughts together if you have anything. Nothing. Oh, I know what I need to tell you. This has nothing to do with the exam. If you get a chance, please do the teaching a class evaluations. Since we've been on quarantine, students have really kind of neglected to do this. And it doesn't mean all that much for me. I'm a big old professor. It's not that big a deal. But I'm telling you, for the fall especially, and if you get a chance to do it for this class too, please do. But for the fall, if you have, most faculty or more junior than me, it means a lot for them in terms of promotion and things like that. So please do evaluate the courses. If you get a chance to do this one, that would be good too. Okay. And that's IEVAL. I think today's your last day. You've probably been getting emails about this throughout the last week or so, and it'd be great if you could do that for this course, but certainly for the other courses in the fall where you have more junior faculty, where it really does mean a lot. Okay. All right. But besides that, any questions about the exam? Any questions you might have? No? Okay. I know this is a pretty easy course, and it's become kind of an easy course now that it's been taught in quarantine a few times, but that's okay. We understand that people are going through a lot of stress in their life, and if they can use the material like this just to kind of distract themselves from what's going on, and kind of get engaged in ideas and the type of phenomena that we've been talking about, that's fine. We'll see what happens in the fall when we start teaching in person again, how that will change the rigor of the course, if things will become a little bit more challenging, but we certainly understand what you're going through. Okay, let's see. It looks like there's a question here. Yes. Okay, so yes, Carlos, the answer to your question is assuming that you've filed in the with the student services, absolutely, all that stuff is put in once I finish the exam completely, and I put in all the information. Anyone who is given extra time will certainly be given through the Student Services Center, will certainly be given that through this test. Okay, same as last time. I just haven't done that yet because I'm going to put the finishing touches on the test today. The exam will be, yes, yeah, I asked if the exam will be available until Sunday night, midnight. Yes, absolutely. I have to get grades in early Tuesday, so I want to make sure I have all Monday to kind of, look through everything. But yes, Sunday night would be the time, midnight. Great. Any other questions? Okay. Something comes up later on, just let me know. We can always answer questions like that later. But let's go ahead and continue our lectures. And what we have been talking about, as you well know, is this really provocative idea of imitation and what imitation seems to do for us. Maybe as we discussed, this is something you've noticed in yourself before, that in fact you do sometimes notice yourself inadvertently imitating other folks. But what you probably hadn't heard before is that this is something that your brain is doing all the time. And even if it's not kind of creating this overt sort of imitation that we are sometimes aware of, it is going through this imitative process deep in the brain. And not only that, it actually serves a purpose. And we've already discussed the purpose it serves kind of, socially, right? Being imitated kind of facilitates your engagement. It facilitates your liking of the other person, liking of products, that sort of stuff. It generalizes to more altruistic behavior. But imitating also seems to work as a benefit on a more fundamental level. And that's where we was leaving off our last discussion. It seems to benefit us when it comes just to very simple perception. And we made that intuitive by discussing how, as you're learning a skill through imitative practice, that you learn to pick out things about that skill, whether it's tennis or golf or listening to a musical instrument even. But then we started talking about how the brain actually uses our own motor system to kind of help us perceive better. And maybe this doesn't sound so radical to you, but for folks that have been studying perception for a long time, it was a very radical idea about 10 years ago, where the perceptual system, the perceptual brain and the motor brain were really considered to be pretty separate sorts of entities, except where, what we perceive then affects what we do with our motor brain, how we act with our motor brain, how we initiate behaviors. But now what we're finding is that as we're going through and doing the process of analyzing what we're perceiving, our brain is analyzing what we're perceiving, it makes use of the motor system even before any sort of action needs to occur. And that's where we left off talking about that. So let's quickly just review that. The idea here is that we use our motor system to perceive. And that was actually, as I said, a kind of a revolutionary sort of idea about 15 years ago. And the more time has gone on, the more we realize that's the case. And some of the ways we already went through a slide showing that by occupying, your motor system, it affects perception. But now we're going to occupy the motor system at a very deep level, which is at the brain, by using this wonderful technique, this transcranial magnetic stimulation technique, and inhibiting not parts of the brain that we've long known are involved with perception, but are involved with motor behavior, right? This strip here. And we know by kind of, temporarily creating a lesion, just temporarily breaking that part of the brain just for, a few seconds, that even though it's a motor area, perception of things like emotion can be affected, perception of things like how much weight is being lifted can be affected, different types of hand and arm actions. And what's interesting in all these cases, it's not like, when your motor brain is temporarily lesioned around the hand or arm area, you can't recognize that's a hand and that's an arm. You certainly can. What you have trouble doing is recognizing the action, or recognizing the nuances of the action somebody else is performing. So it seems to really have a bearing not on just recognition of the body, of somebody else's body, but recognition of how they're behaving, which is really interesting. So our motor system, that produces behavior in us, also allows us to more accurately perceive the behavior in others. And that's the idea. Now, we did talk about the fact that in some instances, it does seem to be the case that when we're perceiving something, that our own motor system is activated at the level of the muscles, right? So yes, it always seems to be activated to the level of the deep brain, but in certain cases, it seems to be activated to the level of the muscles. And we've talked about that with regard to faces. This is this wonderful example we discussed when we were in the face chapter, that looking at the expression of somebody kind of induces motor behavior in our own expressive facial muscles, right? And in fact, if those muscles are somehow inhibited in doing their imitation, our perceptual ability to recognize and distinguish faces is also inhibited, right? And the idea you should think of here is, my friend who's had Botox a number of times, in theory, she should struggle a little bit more in being able to perceive nuances in facial expression than somebody that hasn't, or before she had Botox, right? Which is really strange. It's just the muscles that are being affected, but it's affecting her visual system. Again, supporting the idea that when it comes to facial expression, at least, one's own facial musculature affects how one perceives other people. That imitative response is kind of useful for perceiving nuances. Okay, so this covert imitation, that's what I'm talking about here. This covert imitation, that's true. For faces, is this true for anything else? Is it the case that whenever you watch, a baseball pitch, are your arm muscles activated? And the answer is, it seems not to be the case, at least in terms of natural situations. Most of what we've seen in terms of this covert imitation seems just to apply to faces and expression. Unclear why that is. That being said, there are ways you can actually show that the muscles can be activated. Okay, so in other words, we know the motor brain is activated when we are doing things like watching a baseball pitch, or even listening to speech or something like that. The parts of our brain that would work our articulators for our own speech are activated, right? But we don't see the activation at the level of the muscle. Okay, that seems to only be the case for facial expression for some reason. But this is great. Our best friend TMS can be used for another purpose. So transcranial magnetic stimulation. What's going to be done here with TMS is not its ability. We're not going to use its ability to kind of break part of the brain for a temporary period. We're going to use it for another purpose, and it can be used very nicely for this purpose. If the pulse, if the way the machine works is not strong and a long pulse, if it's instead kind of like like that noise, that's kind of the noise it makes. It almost sounds like clicks when you're using it this way. It doesn't break that part of the brain. It actually primes that part of the brain. It actually kind of enhances its activity. So it's another way of using TMS. Mostly we've talked about it as a way of breaking the brain, where you put it near, say, the motor area, you turn it on, it breaks the brain temporarily, but it can also be used to kind of facilitate the brain, which is interesting. So it's a different type of thing. It's a very weak, short pulse to the motor area in this case, and it primes the brain. It actually increases its activity a little bit, which is cool. That has had, by the way, just as an aside, has had some therapeutic uses, possibly for treating different sorts of issues like depression and stuff like that. I think the jury's still out on how well that works, but it has been applied in those contexts. But let's talk about it in this context now, which is applying short pulses of TMS stimulation to the motor area to see if now we can induce subtle muscle responses when somebody is perceiving somebody else. Okay, so it's kind of a way of finding other instances of the muscular response, the kind of imitative muscular response that we've only been seeing for facial expression, now with other actions. So it does basically, it does basically prime muscles for covert imitation. So now when you use that little pulse, that kind of weak kind of priming pulse to the motor area, you do see hand and arm motion kind of twitches when one watches, when a subject watches somebody throwing, somebody moving their hand, somebody moving their arm. You do see muscular activity if, in fact, you prime a little bit, and that's useful. I mean, it's kind of kind of artificially setting this up, but you can now establish that when somebody is watching a hand motion by using this priming technique, that their hand muscles will react, not their leg muscles. However, if they're watching somebody swinging in their leg, okay, you will see this kind of little twitching, maybe little muscular activity in their leg, not their arm. So there is that way of kind of priming the muscles a little bit to see what you're seeing with facial expression. Works like that. Interestingly, and this is one of the reasons I kind of took the time to talk about this technique, it also shows that this sort of imitative response can be primed in the brain to the point where it works with auditory, heard sounds, not seen things, right? So everything we've been talking about in terms of imitation has pretty much been related to subjects seeing an action. But it also does happen with listening. It especially happens with speech. And this is going to be something that's going to prove important in our next lecture in just a few minutes. In other words, when one is listening to speech, okay, when you're listening to my speech right now, in fact, areas of your motor brain are actually responding. Okay, so areas that control your own articulators. Let's make it very simple. I'm going to go ba, ba, ba. Areas that would control your own lip motions are going to respond in your motor area. Okay, and now we can kind of play with that a little bit, use that TMS device, just prime it with those weak pulses. And now what you'll see is I make a ba sound. You'll start showing little muscular activity in your own lips, just based on sound. Okay, just based on sound. So, pretend you're not seeing me. I'm going ba, ba, ba. Okay, you're going to show your own lips kind of taking on the muscular activity as if you're producing your own bas yourself. It has to be primed, as we said. Okay, but it's interesting that happens. And as it turns out, I've been kind of talking about this in the auditory context. It also happens if you're not hearing me, but you're seeing me, like that. Okay. So you're not a great lip reader probably, but you'll learn very soon that you do lip read kind of all the time. It is the case that that same type of kind of muscular response in your lips that's primed by that little TMS weak pulse, okay, shows up even if you're watching my speech, not listening to my speech. So that's what this image is down here showing. So, by priming the motor area, with this weak pulse, and then watching somebody articulate, your own lips kind of have these kind of sympathetic, kind of imitative sort of actions. And that is true whether you're listening to or lip reading speech. Cool. Okay, so this is not something that, normally happens without that TMS priming, but, it shows that, boy, like the motor brain is really kind of working in a very imitative specific way. When somebody is making a ba sound, your motor area that's associated with your own creation of a ba sound is in fact activated. And we can show that by kind of giving it a little boost. And actually that activation can then kind of go all the way down to your muscles that are involved in the actual ba, your own ba response, which is kind of cool. So what do we want to make of this? Well, it seems that the idea of imitation, even as we said before, even if it's not something that you are overtly doing, explicitly doing, right? You're not visibly or audibly imitating people all the time, is something your brain is doing all the time, which is really interesting. And it's led to an idea that has kind of been revolutionary in the field of perception and brain science. The idea that your brain is always imitating. And I wonder if you would have heard this in another class. Maybe, I don't know if they teach this in high school, but certainly they would teach it, well, hopefully in an introductory psychology course at this point. Here's the idea. That historically, we used to think that the cells that were associated, the neurons, the brain cells that were associated with perceiving were very separate from the brain cells that were associated with acting, right? So I'm watching, something here, the screen, what else? The beach, right? The wind blowing the trees, all that sort of stuff, right? And that's a separate group of brain areas and brain cells that are controlling the muscles of my arm as I do this sort of thing and my articulators. So these are very separate sorts of things in the brain. And now you know a little bit more. Like it sounds like they are actually talking to each other. But we're going to now discuss the fact that cells, individual cells, can actually play dual roles. Here's what happened. This is an anecdote. It's always fun to tell anecdotes. I don't know how true it is. I think it's fairly true, this anecdote, but this is something that happened in the early 2000s, where a laboratory in Italy was doing some research on what's called the action planning cells of chimps. They were interested in what cells were going to be involved with what sorts of motions. And so, the chimps were, happy, treated well, but they did use some brain kind of measuring techniques where the little electrodes were in the cells of the animal's motor area. And they found that if they stimulated these cells, or let's actually work the other way. They trained the monkey to reach. Okay, they train the monkey to reach. And the way they do this, they put raisins, and monkeys, I guess, love raisins. They train the monkey to reach, and they look to see what cells in its motor area were activated. Okay, what cells are involved in that reaching behavior, right? All right, cool. And they were mapping them out, and they did, okay, this is great. We're really learning a lot. The monkey's having a nice time too. He's eating raisins. There's no pain up here or anything like that. They're eating raisins. The surgery is fixed and everything, and they're perfectly happy little monkeys. But monkeys, enjoy the raisins. And so the story is they were giving the monkey a little rest. Chimp, by the way, but that's okay. Monkey sounds cuter. I guess at one point, this is the story, that there was a grad student working there, and I guess the grad student was hungry and felt comfortable with the monkey. And so while the monkey was resting, the grad student reached out and actually took some of the raisins. See, grad students don't get paid enough. They have to eat monkey raisins. The grad student reached out and started taking some of the raisins. And the monkey was kind of looking at him, didn't mind, right? But what they found was really interesting. The cells in the monkey's brain that were used to initiate the monkey's behaviors also responded when the monkey was watching somebody else produce those same behaviors. As the monkey was watching the grad student, reaching out and grabbing raisins and eating them, okay, those cells in the monkey brain were responding as if it was the monkey actually doing it, right? So it responded to seeing the same movements it was that those cells were involved in when the monkey was making the movements. And they started, they say, why should this happen? There must be something wrong with our measuring technique. Maybe we didn't get the right cells as we measured. But they did it. They found this again and again, and they then found that there were other types of movements that worked like this. They found the movements that the cells that were involved with the monkey raising its legs, and they said, yeah, whenever the monkey raises legs, these cells go off, and these are in the motor area, so they must be involved. And I guess they could stimulate them as well. They could stimulate these cells, and the muscles of the monkey's leg would move a little bit. Yep, these are the cells that are involved in the monkey's motion of the leg. But then when the monkey watched another person move their leg, or another monkey, but a person as well, okay, in the same way, those cells would again respond. So it seems that like some of these cells in the motor area of the monkey, okay, have kind of a double duty. They have two purposes. They are involved, very clearly involved in initiating behavior, but they are also responsive in watching somebody else performing that same behavior. In other words, these might be the sort of cells that are involved in this kind of covert imitation that we've been talking about the entire time, right? They gave them a name at the time, and they called them mirror neurons. And this has now become kind of a big story, that there are cells that have this kind of double skill, that they not only initiate a very specific behavior, reaching with the hand, moving the lower leg, moving the mouth, that sort of thing. And they also respond to seeing another person, another animal doing the same thing. And for monkeys, they have to be looking at other monkeys or people, okay, doing the same thing. That's really amazing. So this is kind of a way of kind of finding the kind of, the very specific sorts of cells in the brain that might be underlying everything we've been talking about in our discussion of imitation. And the fact that our brain seems to be using its motor system to help perception. Okay. After that, they said, wow, this is great. Is this specific to monkeys? Probably not. It probably works. Typically when you see something that's that, profound in a primate, it applies to other primates, and it absolutely does. We now know that people also have these sorts of cells. This is doing single cell recording is trickier with humans, but it has been done, and cells have been identified. But typically, when we talk about these kind of mirror neurons with humans, we don't talk about specific neurons. We talk about a mirror neuron system. So there is, now we know, an area of the motor brain that is involved, that includes cells that have this double duty, that not only initiate specific actions in human behavior, but also are involved in perceiving those very specific actions when somebody else is performing that behavior. So there is this analogous area in the human brain, without question, and it is something that's active and does seem to help with perception. And in fact, you can come in now and show that by using very precisely targeted, big pulse, kind of a lesion pulse of the TMS device, that you can affect perception. So, it is the case that these areas are affected by the lesion type of transcranial magnetic stimulation that we've been mostly talking about, right? So, you can kind of map out that, yes, this area of the, it is this area of the motor brain that initiates, say, facial actions, right? It is this area of the brain that also is involved in perceiving facial actions. And so in that area, we have a group of cells that seems to have double purpose. Okay. Not only can they initiate actions, they can also be involved in detecting and perceiving these actions. And with regard to imitation, all right, what you find is that these cells, these groups of cells, are most active when we are imitating. Okay, so they found this with the monkey right away, right? They trained the monkeys to only reach when they were watching somebody else reach. Okay, so let's share the raisins, monkey. And so the grad student reaches, and the monkey coordinates its reach. It's kind of fun, back and forth like this. And boy, those cells, those mirror neurons, go nuts. They are most active during this kind of explicit instance, this kind of overt instance of actually imitating. right? That's when these things are most active. And that discovery was really profound. It's like maybe that these are the sort of cells that certainly are involved in imitating. They are certainly involved in this kind of implicit, this kind of hidden imitation that our brain is doing all the time. But maybe they go beyond that. And this is where things get a little bit more controversial. Everything I've said so far, I think, has pretty much been established that these types of cells help us perceive, especially when we're talking about, kind of fine-tuned perception and that sort of thing. These sorts of cells are going to be involved. And the fact that, there are cells that are involved in motor and perceptual behavior, individual cells or cell regions, is a really, really important thing. However, when a big discovery like this is found in almost any science, sometimes it tends to be pushed. The question is that pushing to new areas that we're going to see it had been applied to? Is it supported? So, for example, things like empathy. Is our, ability to empathize with what other people are doing related to these areas? Okay. You might know that individuals that are far on the end of the autism spectrum, right? So they have pretty severe autism. They have a lot of difficulty performing imitative behaviors. Is their mirror neuron system different from individuals who aren't that far on the spectrum, right? So, I mean, you can see, these ideas are being applied in different areas. So let's talk about that a tiny bit. One thing that always comes up with regard to kind of this kind of reflexive imitation, and I think it's worth talking about, is yawning. So, you've heard yawning is contagious, right? I'm sure you're all yawning now, and that's contagious even though you can't see and hear each other. No, I'm kidding. But you've been in classrooms, you've been at parties, and it's getting a little late, and some people start yawning, and maybe you find yourself yawning as in an imitative sort of manner, right? And yeah, it does. I mean, yawning is contagious, but it is somewhat constrained by familiarity. So you are more likely to contagiously yawn based on a friend's yawning or a family member's yawning than somebody who's a stranger. But we do believe that, in fact, I think there's research pretty much confirming that it is related to our mirror neuron system, that when you see somebody yawning, their whatever sort of musculature is involved with yawning in your motor brain is activated, and often it can activate to the point where it can induce your own yawning. So I think that's a good example, but importantly, it is modulated by something. It's not like every time you see somebody yawning, you automatically yawn yourself. There's something that also plays a role related to, your, social comfortability, right? But it probably is your motor brain that is involved with this. What about this? What about others' intentions? And I'm not going to get too deep into this. It's an interesting question if you're into this type of thing. But is this our way of perceiving what other people intend to do? Because this is a really important part of our kind of behavioral and our perceptual repertoire, being able to perceive what others are planning on doing and being able to either coordinate with those people if we think they're doing something that would be helpful for us or they need help with, or if they intend us harm, we need to know that. We need to really perceive what other people are planning on doing, on a very kind of short-term basis really, really well. And just thought that maybe that's one thing that this system is for, is perceiving other people's intentions. And there is some evidence for this, because just let's go back to the monkeys for a second. If in fact the monkey sees the raisins there, okay, and then so the monkey sees a plate of raisins, and then a board comes down and they see a person reaching behind the board as if it's towards the raisins, but they don't actually see a person grabbing the raisins. They just see there's the raisins, board comes down, then they see a hand going for the raisins. Their mirror neurons will still be activated as if they are perceiving basically the entire action of grabbing the raisins, suggesting maybe what they're perceiving is not just the literal action that's kind of inducing activity in these cells, but the intent of grabbing the raisins and eating them, even if they're not literally seeing that grabbing action, right? So that's another kind of speculation on what these areas or cells can be helpful for. Not just, not only are they helping us perceive the literal actions of somebody else, but the intended actions, even if we don't see the entire follow through of those actions. What about autism, though? Okay, I have not kept up on this literature, and I imagine some of you maybe know the autism literature better than me, based on maybe working in clinics or having taken other classes. So I'm going to tell you just what I know as of 2000. Probably I looked at a little bit after the book came out, 2012 or something like that. And there was some sense that maybe the mirror neuron system is differently activated in individuals with autism. Okay, so as I said, you do see, especially with people with severe autism, you do see people have less imitation. Their imitation of facial expressions is not, that kind of you don't see that sort of kind of muscular, kind of imitation with people that have severe autism, right? Sometimes these people, kind of almost need to be taught to have sympathetic sorts of expressions and that sort of thing. They even show less contagious yawning. Okay. By the way, animals show contagious yawning too. That's why I have that little chimp down there. Between animals, and also there's some, when your doggy yawns, yeah, there is some contagious yawning between you and your doggy. Not as much as between people, but still. But people with autism don't show that very much. They don't show that sort of kind of reflexive imitation, either in kind of the muscles of facial expression or in yawning, suggesting maybe something is a little bit different there. And when in fact they are watching, somebody performing a task, they do show less activity in the mirror neuron system areas of their brains. Now, what does that mean? Well, it means that there's some involvement, but it doesn't necessarily mean that this is the seat of, this is where autism stems from, is from the mirror neuron system or anything like that. Autism can be very, very complicated. It can be very, very different in different types of people. So, you have to be very cautious before you can make any claims about, a system, being the basis of autism or something like that. But it's interesting that you do see, as of 2012 at least, you do see this sort of involvement. And then finally, as I mentioned, empathy. So, you have friends that you consider more empathetic or less empathetic people. Maybe you consider yourself a very empathetic person, maybe less empathetic, right? Does that have anything to do with mirror neuron systems? Is our kind of mirror neuron systems ability to kind of, kind of infer the intention of other people, is that at all related to how empathy kind of is manifest in other behaviors? And again, this has to be taken with a grain of salt, right? This is a really cool discovery, this mirror neuron system, but it is something that, it's relatively new, and you have to be careful not to overgeneralize. But in fact, you do see, as of 2012, I'd say, that you can ask people to rate their empathy, their self-perceived empathy. How empathetic are you? And I think people aren't terrible at this. They have some sense of how empathetic they believe they are and how other people might see their empathy, and how responsive their mirror neuron system is. So there's this correlation. I don't know if it's held up since 2012, but there was this correlation where the more empathetic somebody rated themselves, the more activity would be shown in their mirror neuron system of their brain when they watched somebody else's behavior. And we're talking about very, kind of simple, low-level behaviors. We can all watch somebody reaching out, we can all watch their legs move, and our mirror neuron systems will be involved. But when watching those simple behaviors and being a very self-evaluated, empathetic person, there is even more activity in the mirror neuron system than people who rate themselves as less empathetic people, which is interesting, Okay. I don't know whether that's held up. That's the sort of thing you have to be very careful with completely. But, I thought I just kind of put the idea out there for you. I should probably look at that again to see if it has held up. Okay. Any questions on this before we continue? Sometimes people are interested in this type of thing with empathy and autism and anything like that, or should we continue? Okay, we'll continue with this. One more thing I want to talk about with regard to imitation, and then we'll take a little poll question and shift our topic. Okay. One other thing I think that's really interesting about imitation is how it guides not just our perception, but our attention as well. And here's what I mean by this. This was a really fun part of the book to write. If you've read it, you'll know why. But it has to do with this. It has to do with magicians. And I'm going to show you a little magic trick. Sometimes this video is a little kludgy. Hopefully, I'll get it to work. This is just a very simple magic trick. He's actually this guy. I know him. He's both a perceptual researcher and a magician, and he is going to perform a magic trick. And then I'm going to talk about how they measured the audience response to this magic trick. So let's look at the magic trick first. Silly, but still, you'll get an idea about it. Yeah. Okay. Hopefully this will work. Come on. There he goes. Sorry about this. So for some reason, this video, hold on. Here we go. Ta-da! Okay, so a little magic trick. If I hadn't told you it was a magic trick, or you hadn't been primed to look very carefully, it would probably work on you. I don't know if it worked on you. Certainly, first time I saw it, it worked on me. You see the lighter disappear, you see the cigarette disappear, you don't know exactly what's going on. I'll play it again. Now you do. So this will actually help us. I'll try to play it again. Here we go. Takes the cigarette out, puts it in his mouth, puts the wrong end in his mouth. I don't know if you can see that, but the wrong. So he looks at the cigarette, he switches it, but the lighter has disappeared. Where'd the cigarette go? Okay, you get the idea. So let's pretend it worked on you, that you didn't know how these things disappeared. Let's see. Is it working on anybody? Carlos asked a question. So is part of autism a malfunction with mirror neurons? So that is exactly the question, Carlos. It's a very, very good question. And I would say that when I was writing the book, there was speculation of that. And I have to say that I have not completely kept up on that. So I want to be very cautious. But I actually have seen talks recently, 3 years ago, before quarantine, that suggested that people do think that there is some involvement, but certainly autism is more complicated than that. Okay, good question. All right, anyway, let's go back to our magic trick. So what this researcher did is he put this in front of people. Actually, I think he showed them a much larger version of this video, and asked them to watch it, and then asked them how they thought the magician did it, or was the magic trick effective, all that sort of thing. Okay, but they did something very clever. Not only did they do the magic trick and ask them their experience of it, they actually tracked where the audience, where the subject was looking during the magic trick. Okay, and what they found was something very interesting. That in fact, okay, so by the way, this is a very simple thing to do these days. In the old days, it was complicated, but now you can just basically buy a little so what are those cameras called? GoPro cameras. It's actually smaller than that, and you kind of hook it to the front of a baseball cap, and it comes down a tiny bit, and it's very easily tracks your eye movements. So it's a very inexpensive thing to do, and I think you can buy one of these for under $1,000. So it's really simple to find out where subjects are looking as they're perceiving different types of stimuli. Okay, and they were interested in where the subjects were looking while they were watching the magic trick. And what they found was that despite the movements and all that sort of stuff that the magician was going through, the audience, the subjects gazed mostly where the magician was gazing. So here, let me put this up first. What you're seeing here is this is the measure of where the subject or the observer is looking. This is a measure of where the magician is looking. Okay, this is just where they can look at that from the video. And here are the actions down here of the actual magician. And okay, let's look right here. What happens here? So that you probably noticed at one point that when the magician was taking out the cigarette and kind of pretend to light cigarette, move lighter. Wait, hold on just a second. Right. While the magician was looking at the cigarette and realizing that it was in the wrong orientation, right? What happens then is the magician is secretly dropping the lighter, right? And what you find here is that the audience starts looking at wherever the magician is looking with a little bit of a delay. Okay. So, if I'm the magician and I don't have anything here to do magic trick with, but I want to do something secret with this hand, I'll look at this hand and I'll do something secret with this hand. My gaze, where I'm looking, is going to affect your at least attention and probably eye gaze too. And that's what this measure does. So in other words, we seem to have this imitative tendency to look to where others are looking, or as you'll see, if not literally looking, at least our attention goes there. But what this experiment shows is, yeah, very often when it comes to watching somebody perform a task or something like that, as they look around, we try to get as big a picture as possible, but we can't help being kind of distracted and look to wherever somebody else is looking. There's research that suggests this that you can read about, but I think it, besides this, that I think is really interesting. I won't have time to get it today, but it seems that that is something that occurs. And magicians know this. This is one of the cool things. If you read through this, you know that I interviewed a very well-known magic teacher at the Magic Castle in Hollywood. And he said this, he said, yeah, we know as magicians that the audience will look or at least attend to where, we as magicians are doing that. So we exaggerate the motions a little bit. We exaggerate where we're looking, right? Knowing the audience's attention will go wherever I'm looking. And that's when we do something secret with the other hand, right? That's just a well-known magician's technique, and they'll tell you about it. That doesn't mean it's not going to work. It's probably still going to work on you. Once you see the trick and you know how it's done, if I show you the exact same video, then you can see through it. But typically you're not seeing tricks over again. It's one reason magicians don't do it over again. And so when somebody is looking, when the magician is looking at the hand, the audience is also attending in that direction. That's the secret move. They also know that there's a little lag in that. So the magician will look at the hand, and they know that it's going to take about a half a second for the audience to kind of catch up. So they will delay. And they don't know about the research. I should mention this is not because they've read the research on where people's attention or eye gaze goes during something like this. They just, they've had lots of practice. And when I asked the teacher, they said, yeah, no, you just learn from practice that the most effective way to do this is after you look somewhere, you wait a second, maybe you say something, you use your verbal patter and say, you know, make a little joke or something like that. So you have a half second for the audience to look, and that's when you do your, you know, your secret thing with the other non-attended hand. Okay, so it's a very well-known kind of instance of imitation that occurs in magic performance that the magician uses, and it makes use of almost a reflexive imitation we have to look towards where the magician is looking. However, as I said, it's a tiny bit more complicated than that, because even if your eyes don't literally go to where the magician is looking, okay, your attention does. And here's what I'm talking about. This is another dumb little magic trick. You're going to figure out that it's a magic trick and all that. I mean, imagine yourself coming into the experiment, sitting down, not knowing this is about magic tricks, but you're wearing this little visor where it's tracking your eyes, and you're just told, okay, watch this person now perform this little action, and then we're going to ask you questions about it afterwards. And here's the action. Okay, and people are then asked, okay, what happened to the ball? And without expecting a magic trick, without expecting anything odd to happen, they'll say, oh, it must have, when he threw it up the last time, somebody must have been above him on a ladder or something like that, catching it. Or it was removed by some sort of, you know, computer image manipulation or something like that. And, you know, people didn't quite know how it was done. Okay. I'm going to show you another version of that same type of trick, but I think now you'll have no trouble determining how it was done. The difference between those two performances was pretty subtle, but maybe you noticed it. On that top version, okay, as he was throwing up the ball, the last throw, that, you know, magic throw, he follows where the ball should have gone with his eyes, right? On that bottom version of it, on that last throw, he actually just looks to where the ball truly is, which is in his palm. He's palming the ball. That's where it's kept. Okay, and people find the top version much more effective. You know, or as a magic trick, they'll make up you know, solutions that really have nothing to do with the actual solution of the trick. Where in the bottom version, people say, oh, it's still in his hand. The only difference is where the magician was looking. The one that's more effective is when he pretends the ball is going up and he tracks it with his eyes. So cool. What happens? Basically, this is called, by the way, I should put a term on this. It's called gaze misdirection. It's very, very well-known, used technique by magicians, even beginning magicians. I took magic lessons there, and that's one of the first things they teach you is how to do this type of thing. And they, in this experiment, they go ahead and they did more eye tracking. And this is what they found. Let's look down here, and then we'll talk about what the text I have up there. What this is showing in these three panels, A, B, and C, is what's going on during the three throws. Okay, so this is where the eye is tracking as the ball is going up. You know, these X's, both the X's and the dots, I think, is that right? Yeah, well, basically, let's look at the X's, and I guess it is the dots too. So yeah, as the ball is thrown up, that's where the audience is looking, and that is where the magician's looking. And then on the second throw, the same thing happens. The magician's looking up. On the second throw. On the third throw, okay, the magician is looking up. All right, but the ball is actually staying in his hand. Now look what happens here. Subjects kind of begin to track, but then they come right back down. Okay, so this is where they are looking. All right, so in other words, on that third throw, they begin to track the magician's gaze, but then they follow where the ball is, which is actually, okay, right in the hand. So what's going on here is, you know, before I said, you know, the eyes kind of follow where you're looking, your eye gaze follows the magician's gaze. That's not always true, okay? Sometimes your eyes aren't fooled. right? But you're fooled. And we know this because people say things like, the ball went, somebody was above the magician and caught it. Therefore, that's where the ball went, or, there was it was done, the ball on that last throw was removed. The ball was never thrown, right? But they'll say it was removed, it started to go up, and right when it was at its top position, it was removed by some sort of, image manipulation, computer animation sort of thing or something like that. But it was never thrown up. That's the truth, right? But those people who were fooled by the magic trick actually didn't follow the magician's gaze completely. So even though I said before the gaze actually tracks the magician, it's not always that complete. What does track the magician's gaze is the attention of the perceiver. And magicians know this as well. So I asked my magic teacher friend, do you look around at the audience to make sure everyone's looking at your hand while you're looking at it? He goes, no, it doesn't matter whether they're literally looking where I'm looking, because I know their attention is there. Even if they're looking directly at me, I know, you can, if you look out into what you're seeing now, you can kind of swing your attention, between different things. I see my glass of water. I see the lights over there. I see, two monitors in front of me. I mean, I'm just looking, my gaze is still in one position, but my attention can kind of jump around. And that's what's going on for the audience watching a magic trick. Even if they're still looking right at the magician and not where the magician's looking, their attention is in that hand. So it's as if in these cases, your attention is following the gaze of the magician, even if your eyes are not literally following the gaze of the magician. So, your attention is fooled, even if your eyes kind of reflexively are looking at the ball, which is kind of interesting, right? How does that work again? Again, when you're looking out, you look at where you are right now, where you're sitting there in front of the computer, you can look out in front of you and, you can see a lot of things. You can attend to different things in the room, even though your eyes are steady. And that's what is happening when an audience looks at the magician, even if they're looking straight at him, and they're not looking to where he's looking or she's looking, right? Your attention is going there. And that's what makes the trick effective. That's what makes gaze misdirection effective. So one of the ways we are kind of reflexively imitating someone else is that our attention imitates their attention. And that makes some good sense evolutionarily, right? If someone, looks at seeing some sort of threat coming towards you, you want to be attentive to that threat as well, right? That's one of the ways we kind of keep ourselves safe. And you'll see there's other research that suggests that we can't help but be distracted by somebody else's kind of attention towards something. Some interesting research that you can read about that discusses that. Okay, great. Let's take our little break here then, and not class break, but a little lecture break, and do a polling question. And this is a polling question on, did we do? Yeah, we did inversion effects, didn't we? Yeah. Did we? I can't remember. I don't think we did. Yeah, we did not do inversion effects. Did we do? Yeah, we didn't do facial inversion. Okay, this is facial inversion. This is from last class. Remember at the very end, we were talking about what happens when you invert a face. So here's the question. Facial inversion effects, A, suggest that we use both configural and featural information to perceive faces. B, show that inverting a face makes it disproportionately harder to recognize. C, show that inverting a face makes it disproportionately easier to recognize. Or D, both A and B. And I'll give you a minute to answer this. All right, another 10 seconds or so. Cool. All right, you guys did great. Most of you. Correct answer is D. Both A and B are true. It is the case that inverting a face does make it disproportionately harder to recognize, but it also is a demonstration of configural and featural information. Because when you invert a face, you basically lose functionally all the configural information that would be available in an upright face. So both A and B are true. C, that's incorrect. So you knew that either B or C had to be correct, right? Showing that an inverted makes it disproportionately easier to recognize. No, and that's kind of a gimme answer. You knew that because you know it's harder to recognize faces when they're upside down. Even if you didn't take the class, you probably knew that. Okay, so the correct answer is D there. All right. Cool. Any questions on anything? Because we are going to shift our discussion now and talk about multisensory speech. So we have 2 chapters on multisensory perception in the book, and I'll be talking about the first one. The second one, sadly, I won't have very much time to talk about today. But again, I'd like you to read through it. There will be a couple of questions on the exam from that last chapter. Maybe we can get to part of it. Hopefully we will. Anyway, this is actually my research area. Most of my research is on multisensory speech perception. So this is something I care a lot about. So you can imagine there might be a lot of questions on the exam about this. And I'd like to start off talking about this topic by introducing you to a really interesting woman who I had a wonderful time interviewing. I'm just trying to, 1 second, sorry. There I am. Sue Thomas. And so this is Sue right here. You're seeing her right there. Sue Thomas was, I think, deaf, I think at a very early, I think by the time she was 1, she was completely deaf, as I remember the details. And because of a kind of the way her parents kind of helped her out, she became an astonishingly good lip reader. And this, her story is really interesting with regard to what she was able to do with it. Oh, I'm sorry. She lost, it does say in the slide later on, she did lose all her hearing by 18 months. But that's still before much of her language acquisition. But anyway, this is what her story was. At one point, God, what was this, in the 70s, I believe, the FBI thought it would hire deaf individuals to help with fingerprint analysis, try to match fingerprints. So back then they didn't have the kind of computer technology that would allow, a kind of fingerprint that was taken at a crime scene to match the base of, all the thousands and thousands of fingerprints they just had from, DMV records and things like that. These days there are computers that do that and do it very well, but back then they didn't. So what you'd have to do is you'd have to, kind of visibly match the, the kind of sample fingerprints from the crime scene to the base of all the fingerprints that were available, or at least with the suspects' fingerprints, that sort of thing. And for some reason, they thought deaf individuals could do this better because they'd be less distracted or something like that. And so anyway, so Sue did this for a day. She went in, they hired her, she went into the FBI and she did it. She said it was the most boring thing, and everyone found it ridiculously boring. And, to think that deaf people would be less distractible, in that situation, there's tons of visual distractions, right? But they noticed something really interesting about Sue. She, I guess the second day, they brought her in to the front office, where the bosses were, and she thought she was just going to be fired because it was pretty clear she was pretty slow at it and not really enjoying it. But they said, we've interacted with you enough to know that you are an astonishingly good lip reader. And she said, yeah, I'm fine. I find that pretty easy. I can vouch for that. My interview with her was tremendous. It was, she had no problem understanding me. Anyway, they said, we were wondering if maybe you could help us with something. We just got this kind of surveillance recording where there's no sound, but you can see two people talking on it. And we were wondering maybe if you could help us determine what they're saying. And she said, okay, I'll try. And so they set her up in this room with this really high-tech equipment for the 70s. And she was able to zoom in and see their lips. And she was able to pretty easily decipher what they were saying. And so they hired her now to do this, to become basically a professional lip reader for the FBI. She did it in the context not only of surveillance videos, she also did it in live situations where if a suspect was, say, going to the airport and they wanted to know what they were saying to their friends or whatever, she would be able to sit far enough away where a normal person wouldn't be able to hear them, but she would be able to lip read from across the room. So, and this was, again, she was able to do that very, very well. She did it for a few years. It was hard work, very hard work. She said it was, took a lot of concentration for her, and she was put in some situations that she was less comfortable in. But yeah, she was tremendous at it. And they actually ended up, which is, if you go to her website, you can see this. They actually ended up making a TV show based on this called Sue Thomas FBI. And this is the woman that played Sue, and that's her dog. That's the dog, the actor dog, that's her little doggy. So Sue Thomas FBI, and the I was spelled E-Y-E. It was on for a couple of seasons. I think you can see reruns on YouTube if you look it up. It's interesting. But, I can vouch, she's an amazing lip reader. I mean, during our interview, she only asked me to repeat myself once, and she said I was smiling too much. So what made her such a good lip reader, right? I mean, how did she get to be so good? I'll tell you a little bit about this. She lost her hearing by the time she was 18 months. So she had a sense of what language was, right? I mean, that wasn't, she knew that there were words that stood for things and all that. But, most of her language acquisition, you don't acquire a lot of language after 18 months. Most of her language acquisition occurred in, after she was deaf. And that's something we know about better lip readers. That if they need to use lip reading in order to acquire language, that's something that could improve lip reading as well. Now, I asked her if she had known about any lip reading, if she had gone through any lip reading training, and she said, I've never heard of such a thing. And as it turns out, if you go online, you can enroll in lip reading training. I don't think there's much evidence that you can learn to lip read like this, certainly by taking an actual course. And she said, yeah, I'd be very surprised. She said that she thought that probably wouldn't work in most cases to actually kind of get watch a silent video and that sort of thing and become a good lip reader. She said, no, I don't think it's that. I think it was the amount of speech production therapy she got. So she was in intensive speech therapy to help her speech. And maybe you've heard this before, that individuals who are deaf have trouble sometimes being understood with their own speech because they don't have the auditory feedback they have. By the way, I don't know if you folks have seen the movie Coda. It just came out. It's really wonderful. But it does show, the issues having to do with deaf individuals, own speech and how that is affected. They have deaf individuals, have this very rich culture that's really based on signing and that sort of thing. But Sue, for whatever reason, was brought up in a situation where she does sign, but her main way of communicating with her parents was through lip reading and that sort of thing. But her therapy was really set up for helping her produce speech. And what they do for that, there's a number of different techniques they use to help a deaf person's speech be understood better, is to actually have them speak in front of a mirror. So what they'll do is a deaf individual will watch somebody else articulate something. They'll try to imitate what they're seeing that person articulate. And then they'll go to a mirror and try to imitate it as well. And she did this all the time with both her teacher and parents. Her mom would stand next to her and articulate in front of a mirror as Sue was watching herself in the mirror. So this guided production in front of a mirror not only did help her own speech production, which I can say is very, very good. It's very clear. I had no trouble understanding her at all. But it probably also did help her ability to lip read, to learn to lip read, because she was spending so much time watching speech in the mirror. She thinks that's probably, what helped more than anything else. Whether or not that could help a normal hearing person's another question altogether. But it is the sort of thing that is consistent with what we know of good lip readers. So the deaf are typically twice as good at lip reading than hearing individuals. And there's different ways of testing how good a lip reader you might be, for example, where, you're watching a videotape of somebody articulate something with no sound. And, that would be hard, right? If you turn down if you mute the sound on your TV, it's hard to understand what people are saying, even if they're, like a newscaster looking straight at you. You'd have trouble with that. In that context, a deaf person would be about twice as good. So if you're able to get maybe, in a series of very simple sentences, maybe you're able to get every 1 out of 5 words or something like that. A deaf person would get at least 2 or 3, right, of that type of thing. Someone like Sue gets almost all of them, but a deaf person who's not as good as Sue would get twice as much as the rest of us. It also helps to have an early start, as Sue did, right? She started relying on lip reading at an early age, in her case, 18 months or so. And it was her primary means of communication. As I said, she did learn sign, but later. And she went to a non-deaf, non-specialized school, so she did a lot of lip reading in school as well. And if it's her primary means of communication, then yeah, unsurprisingly, she's a better lip reader than most other people that don't have to use it as their primary means. Other factors that play a role, and I think this is true of Sue as well. Women tend to be better than men at lip reading. We're not quite sure why that's the case, but the excellent lip readers you find, like Sue Thomas, do tend to be women more often. Something called the short-term memory span, and it's nothing too fancy. It's just that it's how much information you can kind of remember for a short period of time. You may have heard of short-term memory, STM. Being able to kind of hold something somewhere between 5 and 9 numbers at one time in our short-term memory, like for a phone number or something like that. Sue probably could do 9 without a problem. What else? Reading speed. She's a very smart woman. She's a fast reader, I would imagine. And as I said, has this probably good short-term memory span. And it really kind of does, it's her experience, her gender, her kind of native intelligence that probably helped her be so good. And again, as I said, it was an amazing talk. She only asked me to repeat myself once in a 2-hour interview. And she was very honest about, why she thought she was so good at this. So I think now she's retired, and I think she does some lecturing and things like that. You can look on our website. It's really interesting. She's quite a colorful and accomplished person. Okay, so what do we know about the deaf and visual perception? Let's go on just a tiny bit. So we're going to come back and talk about multisensory speech in a second. But as long as we're talking about the deaf, I think it's a good place to talk about the kind of cross-sensory compensation that the deaf might have. So we're talking about neuroplasticity in this case. We've talked about neuroplasticity. We've talked about cross-sensory plasticity in the blind, but we haven't talked very much about the deaf. So it's a nice place to, I think, talk a little bit about that. And you do see someone like Sue and other deaf people do show some interesting kind of compensatory sorts of skills. So for example, it is known that the deaf have more sensitive vision when it comes to something very, very specific. And that very, very specific thing is visual motion, especially when it's in the periphery. So what does that mean? I think they do this now in some optometrists. My optometrist does it, where you kind of sit in this, when I get my eyes tested and to determine whether or not I need my glasses updated or whatever. You sit in this big globe, and lights kind of come on from different positions, sometimes in the middle and sometimes on the side. The kind of globe goes around, so little lights come on. I don't know if that's, maybe you're too young to have this test yet, but you're told just to look straight. But they're testing your peripheral vision, right? So if you're looking straight, will I notice that little lights are going on here, all right? A deaf individual would likely be better on average than the same aged hearing individual when it comes to sensitivity in the periphery. And when it comes to motion in the periphery, they show even a greater advantage. Now, why would that be the case, right? Why would there be a visual compensation, but in just that type of way? I think it's interesting to speculate on that a little bit. And what most folks think that study this sort of stuff is that, when we use our auditory systems, those of us that are hearing individuals use our auditory systems for lots of things. But one of the most important things we use it for is kind of like a warning system, right? So, as visually guided animals, you're only able to see what's in front of you, or you can see some of the periphery, but, you can't see anything that's behind you. You can't see if something's in fact sneaking up from behind us, right? So what we do is we use our auditory system for that, those of us that can hear, right? We can hear something, kind of walking through the grass behind us, or, if we're trying to avoid predators in Africa or something like that. We use our auditory system to help us know what we can't presently see. Well, if you don't have an auditory system that can help you with that, then the visual system kind of gets more sensitive to the periphery to kind of compensate for that a little bit. So yeah, you can't tell what's behind you, but you can tell now what's coming up from the side of you faster than if you did have an intact auditory system, right? And we know that that auditory area of your brain does help with that. It kind of, does what the visual brain areas for the blind do. It helps with the other senses, and in this case, helps with more sensitivity to motion at the visual periphery, because it's useful, because it's functional. It helps kind of compensate for the fact that you don't have that warning system that tells you when things are behind you. Okay, that's one thing. What else? Well, you see the auditory cortex, the auditory brain area, responding to motion, responding to, if you know sign language, responding to hand and arm gestures. So Sue knows sign language, Sue Thomas knows sign language. Most deaf individuals these days do know sign language. That kind of efficient processing of seeing language through signing is actually something that is processed by the vacant auditory areas of the deaf brain, right? And so again, it's very similar to what you see with the blind individuals who, can rededicate their visual brain areas to both touch and sound. We saw to some degree as well. For a deaf individual, at least to some degree, those auditory areas that aren't being used for sound are being rededicated to vision and also touch, as it turns out, but vision, as we're talking about it now, in ways that are very functional, okay? That allows them maybe to process sign language more effectively. The auditory brain helps out the visual system. The auditory brain also helps out the visual system when it comes to sensitivity at the visual periphery. Okay, so I wanted to make sure I kind of put that in there. It's discussed again in the final chapter of the book, but there is evidence for that cross-sensory kind of compensation through the neuroplasticity that occurs when the auditory brain is not being used for sound, just like the visual brain when that's not being used for sight. So it's the analogous sort of findings. Okay, cool. That's the discussion of how a deaf brain works, but what about the hearing brain? Or what about those of us that can hear? do we use visual speech? And this is kind of, what we'll be talking about the rest of the class. The truth is we all do use visual speech. And it's interesting. I usually have to convince people of this, that we all do some lip reading to some degree. Now, the lip reading we do is usually added to the speech we hear, but we're often not aware of it. However, maybe now, over this last couple of years, we are more aware of it because of what happened with people wearing masks. And I know this is so true for me. I'm so aware of this. I was out to dinner with my wife and some friends on Saturday, and we were sitting out in the patio as you often do these days, and it was a little noisy. The waitress came out, and I think we had no masks on because we were outside and at a restaurant and all that, all vaccinated, of course. But the staff at the restaurant wear masks, and the gal came out and told us what the specials were. And she had a kind of Southern California kind of, I don't know, I hate to say it, but a kind of valley accent, if you know what I mean. It wasn't thick or anything, but I was having a little trouble hearing it. And I zoomed in on her face, and she had a mask on, and it was like, oh my gosh, that's right. I'm not going to be able to use her facial, her speech motions to help me with this. And it was difficult to hear her. Of course, the mask does kind of quiet the speech sound a little bit, but more than that, it makes it difficult to see a person articulate. It makes it difficult for the brain to do the little lip reading, but important lip reading that we do. And so I think people, maybe you've become more of kind of aware of this, that, when you can't see somebody's face and it's in a noisy context, you don't understand them quite as well, right? Looks like there's a comment here. Let's take a quick look here. Yeah. It's so hard to understand people now. Yeah, I think it is. And I think it's harder when they have a mask on and they have an accent. I think if they're talking fast. Again, we do know that, yes, a mask, depending on the type of mask, does make their speech a little bit quieter. But I think it also really kind of prevents our brains from doing the normal lip reading that our brains are actually doing. So I think this is, for those of us that study visual speech perception and know that we're all doing this, we're all using visual speech perception all the time. We're not that surprised that people are having problems, but people, I think, that don't know this research are being surprised by this sort of thing. In fact, I've got to tell you right now, I'm discussing this with the administration a little bit. I'm not absolutely convinced. You probably have some feelings on this. I'm not absolutely convinced that being in a live situation like a seminar that's mostly discussion in a kind of nice size room, twice the size of the number of students, as you probably know, if people are all wearing masks, I'm not necessarily sure that's going to be a better experience for students than if we're on Zoom. Okay, so I'm teaching a seminar in the fall, and I taught it in the spring as well. In the fall, it's supposed to be live, and it's supposed to be in a large room in the psychology department. It's going to be about 25 students. And I think that if we're all wearing masks and not able to see what each other's faces are doing, including expressions and stuff like that, it's going to be a less effective discussion than if we were on Zoom, no masks, seeing each other's face, hearing each other very clearly. I'm not convinced that live teaching is going to be that much better if we're all wearing masks, at least not in that context. So I'm talking to the administration about this, and they're going to make the final decision on this sort of thing. But I think they should know that we do rely on seeing people articulate, and we do so. This research has been done for decades. We know that this occurs in noisy environments. If you're in a noisy environment like a party, it helps tremendously to be able to see the mouth, the jaw, the tongue articulate. It makes a huge difference. And even if you're not in a noisy party, if you're listening to somebody that has a heavy accent, we know from research that looking at their mouth helps, right? And it's not just, it helps you attend. There's other ways we can test that type of thing. We know having access to the movements of the mouth functionally kind of makes the speech louder for our brains. And even if it's not in a noisy environment, and even if it's not somebody speaking with a thick accent, it is, if it's a complicated message, like, the seminar is going to be, we're going to be talking about complicated things in the seminar, that it helps to be able to see the articulators. And so, yeah, your brain is using the visual information for speech articulation, even if we're not aware of doing it. And you may have seen demonstrations of this type of thing on the internet. Also, I'm sorry. Yeah, a couple other things. Language acquisition. Okay, so you'll find this really interesting. So we absolutely use the face of speakers when we're learning our language. We, as infants, we look at the face of our parents as they're speaking, and it helps us then learn to use the sounds that are important for our language. And in fact, how do we know this? Well, we know this because blind children, okay, who are good hearers, in fact, maybe to some degree, their brains are starting to become better hearers than sighted children, right, actually acquire certain parts of the language a little bit slower. Certain parts, and this is what's really interesting about it. They have trouble, for example, making the distinction or hearing the distinction between the sounds M and N. M and N. Okay, so those sounds, M and N, are actually very close together when it comes to the sound of speech. If you were, moon, noon, on a cell phone, it might be hard to make that distinction between moon and noon, right? Moon, noon. They are very similar in terms of their acoustic structure. And so somehow we have to learn to be able to hear the difference. And we do so by being able to look at the face when somebody says, moon versus noon, okay? The face is very distinct when it makes an M sound versus an N sound. Very, very distinct. And that visual distinction helps us then to hear the difference. We know this because blind children take longer to be able to hear that difference. Blind children are delayed a little bit because they don't have the visual information to help them hear the distinction. Okay. After a while, they catch up fine. I mean, we're talking about a delay of maybe 6 months to a year or something like that. But it is just true with those kind of consonant distinctions where the acoustics are very similar, but what the visual information for them is very different. They can't use that visual information to help them hear the difference. Okay, a couple of other comments here. Thank you for agree. Good. Okay. Welcome, Ashley. She says that thank you for advocating us on this issue. Okay. You're welcome. Okay. Okay. So we know we all use that during language acquisition. However, probably the best way for me to convince you of the fact that you use visual speech perception is this well-known illusion. And this well-known illusion is called McGurk effect. And I'm just going to show you a very simple instance of it. If you're really interested, you can look online. If you look up McGurk effect and go to YouTube, you'll see me. 5 million hits, whatever, you'll see me. My kids think it's really funny that I went viral, but I'm not going to show you the one that looks like this. I'm not going to show you that one. I'm going to show you one that's very simple. Let's make sure we can all hear it. And sometimes over Zoom, there's a delay, so it might not work that well for you. So if you want to be convinced, go ahead and look at that embarrassing video of me later on. But instead, I'm going to show you just this. This is the bottom half of a person's face. And this person's just going to say some syllables. And I want you to watch the face and listen and tell me what syllables you hear.
Ba. 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 Ba.
Okay. I'm going to stop it. So most people hear ba, va, da, va, that sort of stuff. And now what I'm going to do is I'm going to play it again. It's just on a loop. I'm going to play it again, and I want you to look away. Don't look at the mouth and just concentrate on what your ears are getting.
ba, 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 ba,
Okay, now look again. I'll play it one more time. Open your eyes this time.
ba, ba,
Yeah.
ba, ba.
Cool. Okay. Hopefully it's working on you in one form or another. In fact, what's coming through your speakers is the same syllable over and over again. I think it's ba in this case. But what you're seeing are those syllables, that same syllable, dubbed with different articulations that are seen on the mouth. And so you might have perceived things like ba, va, da, va, and felt like you were hearing those things, even though what your ears were getting was the same thing over and over again. You get ba, 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 over and over again. So what you're seeing is influencing what you're hearing. So yeah, you do use visual speech. You do lip read, even if it's just a sliver of the information a deaf person does. You are able. Your brain is using lip read information to the degree that it actually is affecting what you hear. And that's not completely surprising because that experience of hearing things change. I mean, that works for me. Hopefully it's in sync enough for you to get some of the effect. That works for me, even though I've seen this how many thousands of times. And I feel like I'm hearing a change. It's not like I'm seeing one thing and hearing something else and kind of intellectually putting them together, consciously putting them together. I really feel there's a difference in what I hear. And given what we know about how the brain responds to this sort of thing, it makes sense because your brain responds to this visual speech information, this lip reading information, as if it's sound. And there's lots of different ways of showing this, but one of the first ways it was shown is that people with fine hearing were asked to watch a close-up of somebody articulating different types of syllables and stuff like that. And their brains were scanned as they were doing it. And what happened was, yes, their visual brains lit up, the visual areas of the brains lit up, they were watching something, but also the auditory portion of their brains were lighting up. And while they were watching these syllables. And the same thing happens. You see the auditory brain change its activity, even though the auditory stimulus is saying the same thing. The visual stimulus is affecting it as if the auditory brain is responding to different types of syllables. So that auditory part of your brain, the part that's usually used to understand speech through sound, is being affected strongly by the speech you're seeing. It is, in fact, one of the first instances, documented instances, of the perceptual brains of human observers to be affected by cross-sensory information. Until this finding in the 90s, I think it was, not my lab, another lab, until this finding, we always thought the auditory portion of the brain was just involved in sound. But now we know, at least for speech, it responds to the sight of somebody making a sound, which is really interesting. Okay, let's take our break here and we'll come back and continue talking about this, and I'll give you a practice question and all that sort of stuff. But yeah, let's come back at, I guess it'd be 11:45. Yeah, okay, see you soon. Okay, let's do a practice question. Sorry. All right, let's do a practice question. Let's see here. All right, we'll do one. Yeah, on imitation. And this one is about the distinction between ba and pa, which we unconsciously imitate. So the question is, the feature of speech helping us to distinguish ba from pa, which we unconsciously imitate, is called A, proxy touch, B, Tadoma technique, C, voice onset time, or D, none of the above. Okay, go ahead. I'll give you about a minute to do this. Okay, about another 10 seconds. All right. Looks like this one was a little harder for people, so I'm glad I gave it as a practice one. You'll have this one all set for your test. The correct answer is C, voice onset time. So just to remind you, what distinguishes ba from pa is the timing relationship between when your lips part and when your voice or your vocal cords start vibrating. Remember this? Went through this last class. So when you make a ba sound, you can do it slowly, ba, you can actually feel your vocal cords start vibrating right before your lips part if you do it slowly, ba. Okay. But if you make a pa slow, your lips part and then your vocal cords start vibrating, pa, pa. So that is called voice onset timing. When is the relationship between the voice, the vocal cords vibrating relative to when your lips part? That's voice onset timing. And the point we were making there is that when it comes to pause, we all make our pause a little differently. The voice onset time is different depending on where we're from and you know how posh we are and all that sort of thing. But when we're talking with somebody, our voice onset time kind of comes closer to the person we're talking with, and their voice onset time comes closer to the one that I'm talking with. And that turns out to be one of these kind of very impressive examples of unconscious inadvertent imitation where, you know, we're shifting things just at such a minute scale that you really can't even try to imitate that with any you know, kind of subtlety at all. Proxy touch, that's not correct. That's A. That's the instance where you're using tools to touch things. The Tadoma technique is when you're using your fingers and hand to perceive speech. It is related to speech in this case, but it's not really relevant at this point to this unconscious imitation we were talking about. And it doesn't, you know, it's not a cue to distinguish ba and pa. It's just an overall technique to perceive speech. So the correct answer is C, voice onset time, that we had abbreviated on the slide, I think is VOT, or I also put it as voice onset time. So there you go. All right, hopefully you'll remember that for the test. I'm sorry not too many people got that one correct, but that's good, I guess, right? So you'll just remember that for the test. Okay, terrific. We'll do a couple more, I think, practice questions today, just so you can have 4 practice questions. Okay, but let's continue with our discussion. Any questions about anything right now? Any questions about the test or any questions about the lecture so far? let's go back to this. Make me big. Oops. Cool. All right. So just quick review of this slide. We started talking about this visual speech perception, perceiving speech from faces as something that that Sue Thomas did astonishingly well. And we talked about, the fact that there are some people, mostly deaf, who are amazing lip readers. And then what distinguished them, what made them amazing lip readers. Then we talked a little bit about the plasticity of deaf individuals as a kind of a place to talk a little bit about it. But really, what we're going to be talking about the rest of our discussion of visual speech perception, of multisensory speech perception, is the fact that we all do this. We are not as good at silent lip reading as Sue Thomas by any means. It's not as if you can turn off the sound of a newscast, and even though you're seeing the newscaster straight on, you're getting a nice view of their face, you're not going to be able to lip read everything they say. But the lip read information that we are able to use integrates so well with auditory speech that it influences what we hear. Okay? So the truth is, you are using visual speech information all the time, usually in the context of noisy environments and heavy accents and things like that. But even in these cases of the McGurk effect, it's a very clear speech signal, there's no accent, there's no complicated message, your brain can't help but integrate visual speech, which is really interesting. And it's been an interesting topic for me forever, but it's also become a very interesting topic to the field because it's showing that, the idea of our senses integrating is one of the most important things our perceptual brains do. In the old days, we would study vision separate from audition and talk about the brain areas being separate. But, partly for research in this domain, in visual speech perception, we know that the brain is designed around multisensory information. And in some ways, when it comes to speech perception, doesn't really care whether we get this information through our ears or eyes or, as you know, our skin. So let's talk a little bit more about that research. Speech perception is a multisensory function. So first of all, going with the McGurk effect, there is like one of the classic examples. And I think that was one of the ones that I demonstrated. So your ears got ba, your eyes saw him produce a ga, and very often that is perceived as a da. So it's interesting. In this case, there's kind of a integration that produces a new perceived syllable. And again, interestingly, it seems that it works well enough that it actually changes your activity in what we thought was just solely the hearing part of your brain. It works on all language backgrounds. So regardless of your native language, there's going to be some form of the McGurk effect that works on you, right? It might not be this combination of syllables, right? So for example, if this is not an important distinction in your language, you might not get this version of the McGurk effect, but there will be some version of the McGurk effect that you will get. The one that's strongest for us is the one that's in that embarrassing video of me on the beach, if you've seen that, the one with all the hits, if you take a visual fa and put it with an auditory ba, very often what people hear, and almost 98% of the time we find in our lab, people will be reporting that they are hearing va, even though what they're getting in their ears is actually a ba. So it's a very strong effect. And that tends to work across most languages, but even if that one doesn't, another combination will, okay? It also works with pre-linguistic infants. And this is a research project that, well, a lot of people have now replicated this, but something we did in my lab in collaboration with an infant lab up in Toronto. You can read about it in the book, the study, but we were interested to see if it in fact worked with infants that hadn't yet really learned to speak. And so we tested 4- and 5-month-old infants. And it's very hard to understand what they're perceiving. You can't just ask them. You have to come up with other kind of sneaky little techniques. And in our sneaky technique, what we did is we tested how quickly they got bored. And it's a very simple thing to do. You could, it looked exactly like what you're seeing here, the infant sitting on its parent's lap. They're watching a screen of somebody speaking, like the McGurk effect. In fact, it was very much like the one that you saw. And then we know something about what they're perceiving just by evaluating how quickly they get bored. And when they get bored, they make it really obvious. They'll look at the screen really intently when they're not bored. And when they get bored, they go, oh, like that. It's hard for an infant to really kind of pretend they're not bored. Now, let us go. It would be very, very conspicuous about it. And I won't get into too much technical detail here. You can look at the book to do that. But basically, we just tested if, in fact, we played a va, va over and over again to them. So it was an auditory va, visual va. It was perfectly compatible, va, va. We tested how quickly they get bored. Okay. But then if we played an auditory va and a visual va, which adults, as I said, typically perceive as va, will the infant perceive it as va and get bored more quickly because they just heard a whole bunch of vas, right? And in fact, they do. So, so there are components to that experiment, but if you're interested in how you would do something like that, that's one of the ways is you test how bored they get, how quickly they get bored. There's other ways where I think I mentioned, you can test pacifier sucking rates and things like that. But for infants that are 4 months old, it's very simple to measure how they're getting bored and what they're perceiving by that route, suggesting that, that this sort of integration is happening really, really pretty early. There's other evidence that, not with McGurk type effects, but other type of audiovisual effects, that 2-week-old infants are actually integrating the information as well, which suggests that, yeah, we are pretty much born with our brains ready to integrate information across the senses in very sophisticated ways. As it turns out, there's a lot more information available on the face than we ever thought. Bringing in not folks like Sue Thomas, but just undergraduates that are, healthy hearing individuals, in their 20s, what they will be able to perceive from a face is things like intonation. So they'll be able to look at a face and watch the face say a sentence and really actually be able to determine whether the sentence is a question or a statement. Is it time to, the question might be, let's think of a sentence that could be asked as a question. The test starts tonight versus the test starts tonight, right? I think the sentences were a little longer than that, but at better than chance levels, folks could determine whether the talker was articulating that sentence as if it were a question or a statement, like that. Tone, which I thought was really interesting. There are some languages that have segments, important segments that are distinguished by whether the tone of a syllable goes up, ma, ma, like that, or down. Mandarins like that, for example. Pressure, don't worry about too much. It's how much, I'm not going to ask you about pressure. Don't worry about it. Accent, though, is interesting. Individuals can determine whether somebody is speaking with a foreign accent based on just lip reading them. So there's a lot more information than we used to think available on the face. But this is kind of cool, this next demonstration. It seems that this kind of use of visual speech information is so automatic that you don't even need to know that you're looking at a face. Let me talk a little bit about this old experiment of ours, done before you were born, probably. This was in the 90s. And what we did, and we talked a little bit about these sorts of stimuli before. These are what's called point light stimuli. Remember we talked about point light walkers. Now, we're talking about speech, so you probably know these are, this is going to be point light, but not now walkers, but faces. But here's what we did. Pretend you didn't know that. And pretend you came into an experiment and you were just shown that image of the dots, white dots against a black background. And you were asked what it was. And without knowing the context, you'd say, I don't know, maybe a constellation of stars. Maybe someone just splattered ink, white ink against a black background or something like that. I have no idea what it is. Okay, fine. Now we're going to show it to you moving and then see if you can tell what it is. And I'm going to turn off the sound here. So we showed it to them like this. And maybe a third of the people at that point could say, it looks like, I don't know, maybe a face or something like that. I mean, it's not hard for you folks because you know exactly the context. Okay. But still, 2/3 didn't know. They guessed, I don't know, maybe it's an undulating constellation of stars. Maybe it's a kind of a dot butterfly or something like that. We got some really creative sorts of responses. We had to convince them this wasn't like a Rorschach test, or not. We're not looking into your emotional, deep life or anything. So people had trouble. Then what we did is we said, okay, we're gonna use these images still, but we're gonna present it along with syllables. And with syllables you'll hear through headphones. And what we want you to do is watch this image, but report to us what syllables you're hearing. Okay, so I'll do that.
Ba, 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 ba.
Now, for me, that works. I'm not sure. It's probably not working for you. It's a much weaker McGurk effect, but we showed it to them on a big screen. It was synchronized well. And about half the time, pretty much everybody we did this with said, I'm hearing ba. Now, you probably know it's this now classic example of auditory ba. In other words, their ears are getting a ba. But what they're seeing is actually this face that's been constructed with these points articulating a ba. Okay, so we are able to induce the McGurk effect with this. Okay, not as strong, not as strong as if you were seeing the entire face, but about 50% of the time. And at the end, without telling them they were ever looking at a face, we asked them finally what they were looking at. And at that point, about 2/3 of the subjects say, yeah, that's a face. I understand what you're doing. You're showing a face articulating, and that's why I'm hearing these syllables. Good. What about the other third? Okay, they reported again things like, I don't know, it's this undulating constellation of stars. It's a flapping butterfly that you're presenting along with these syllable sounds. I don't know what the image is. Okay, we were a little surprised at that point. But then we looked to see if the subjects who didn't recognize it as a face still showed the McGurk effect. And the answer was yes, which suggests that you don't need to know you're looking at a face in order for your brain to use this visual speech information to integrate with what you're hearing. Okay, which is pretty astonishing. Your visual, your auditory brain, your speech brain is so ambitious in looking for speech information, whether it's heard speech or seen speech. It doesn't even need to know it's looking at a face to somehow extract that information and integrate it into what people report hearing. So the McGurk effect works even if you don't know you're looking at a face, which is pretty wild. It also works, and you might remember this, in the context of touch, right? So we've seen this before. We saw it with Rick Joy and Helen Keller. This is Tadoma, right? This is the general technique you use to perceive speech. And we talked about Rick's ability and Helen Keller and how they used it as their major source of speech information. But I also did quickly mention this one study where people that were not deaf and blind, they were hearing and seeing people, came into the lab and were quickly told, can you feel the difference between ba, va, and da? And they said, yeah, I can. Ba, va, da. And they just made sure, good. Now they were presented as these subjects were touching the face of the experimenter, they wore headphones where, for example, a ba was played over and over again that was heard to be synchronous with what they were feeling on the face. And if the experimenter whose face was being touched was articulating va, va over and over again as the subject was hearing ba, they would report hearing what they felt. So you can get these sort of McGurk effect type influences with touching a face. Now, I think this is kind of profound. This isn't my research, this is a colleague's research. I think this is kind of profound because this is a mode of speech perception that these subjects never at least consciously used before. I mean, maybe you touch a face when you're a baby and you're listening to speech, I don't know. Maybe when you're being romantic, you're touching your partner's face as they're speaking. I don't know, but very, very infrequently, and certainly not for the purposes of trying to perceive speech, right? So you come in for the first time and you're really trying to do this. And even in that context, the speech information you're getting through your skin integrates with what you're hearing. This is, by the way, oh yeah, it doesn't work as strong as that McGurk effect that you're seeing, but it does work, and it works in a systematic way. Again, it's as if that part of our brain in our auditory areas that is trying to analyze speech information is looking for information for speech, information for a person articulating speech, and it can get it through sound, as it often does, through sight, as now you've learned, you can't help but integrate this visual information, and through touch, which it's never, at least intentionally, done before. But still, regardless of where this information comes from, sight, sound, touch, it's immediately integrating it and influencing the auditory brain to think it's hearing a type of speech, which is pretty wild. It's not like you need a lot of training to be able to integrate. You need a lot of training to be able to do what Rick Joy and Helen Keller does, but you don't need a lot of training for what you feel to integrate with what you hear when it comes to speech, which is really interesting. There's other examples of this too. I'll just go through this very quickly. You can McGurk yourself. Sounds terrible. You can McGurk yourself if you want to. You can listen to somebody articulating ba, ba, ba over and over again and articulate silently to yourself as you're hearing that. And what you feel on your face, okay? What you feel on your lips and your teeth and your tongue, what your kind of muscle tendon system is doing down there, that will influence what you hear as well. That's called a kinesthetic. Don't worry too much about that term. It's just that, it's an example of how when your own articulators are stimulated as you're producing a syllable, can influence what you're hearing. And the other example of this, you can set this up passively, just meaning that rather than you intentionally going va, 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 you can have this very evil looking robot kind of stretch your articulators gently as you're listening to speech. And how your articulators were stretched will influence what your brain ends up hearing. So your brain, again, your speech brain is looking for speech information all over through any sort of sensory modality, whether it's sight or sound or touching with our hands or having our own faces touched and stretched, okay? You don't need kind of this experience. These are kind of unique instances where this probably hasn't happened to you before. Rarely has a robot ever pulled my face, but it would influence what I hear. Right. So cross-modal experience isn't really necessary. It's not like, this McGurk effect has to be based on, the experience we've had in hearing and seeing speech. You can have these cross-sensory influences even without that type of experience. So I see there's some questions. We'll get to those in a second. But the idea is this: when it comes to speech, what your speech brain, the speech parts of your brain, probably here in the auditory cortex, are looking for are types of information that can tell us about articulation, that can tell us about what a speaker is doing as they're articulating speech. And it really doesn't care about the sense that it's using. We think of speech as something we hear, but now it's something that we hear, see, and can even feel if we are put into that situation. And that part of your brain doesn't care. It just wants information about what's going on out there, and it's willing to use all the senses to do it. So the point of this is there is a flexibility in your brain where really which sense the information is coming through is not that important. It needs to know, your brain needs to know what's going on out there, and kind of is very, very flexible when it comes to which sense it's going to use, which is kind of consistent with the other things we've seen about cross-sensory plasticity and things like that. Okay, but even with those of us that have healthy sensory systems or relatively healthy sensory systems, it is the case that we're integrating information across the senses, and the brain is trying to find what's out there. Okay, chat. Yeah, Yanni Laurel. Yeah, that's interesting. Yeah, that kind of illusion is a really kind of interesting example of this, where people weren't, I guess, depending on how you were listening. It's not really related to visual speech, although I'm sure you could induce one or the other by having it paired with visual speech. But it was an interesting example where any ambiguity, this major ambiguity in the sound, depending on where you attended to, would make it sound like one or the other. It's a good question. Is the vibration coming from their face? I assume you're talking about the example where you can kind of McGurk yourself, or have by silently articulating, or have your articulator stretched as you're listening. And in those cases, you're saying that the image shows there's something on her throat. Actually, I think these are just the wires. You're talking about this? I think these are just the wires of the headphones. No, there was nothing. I see what you're saying. That's a good question. So does the voice need to be involved in these sort of examples? No, I don't think that's connected to her throat. I mean, I know the study pretty well. I know her pretty well. I think those are just the wires from the headphones. I think all of this is done with, as I remember, just two contacts, and her face is either being pulled this way or this way, and that's enough to change what she's hearing. Oh, the middle image? It says the middle image. Oh, you're talking about this one here, this middle image? There's something on her throat. I'm having trouble seeing this right now. Hold on a second. No, I don't think there's anything on her throat. The man with the hand. Oh, you're talking about Tadoma. Okay. Is the right? Yes. So remember in our discussion at Tadoma, that it's very important that they feel the vibrations in the voice box and the vocal cords here. And in fact, now you know a little bit about why that's important. In order for them to perceive the difference between pa and ba, they're able to perceive the voice onset time. They know, it's a very subtle thing, but if the lips part before the voice starts vibrating, before the vocal cords start vibrating, then it's a pa. And if the vocal cords start vibrating either at the same time or maybe a tiny bit before when the lips part, it's a ba. So yes, that's a very important part of Tadoma. I see what you're asking. Okay, great, cool. Thank you for the questions. All right, we're going to shift a little bit here and talk now about not speech perception, but about multisensory perception for determining who's talking. I think you're going to find this really interesting. Some of it was conducted in our lab, some in some other labs. Oh, let's do a question. Let's do a question since we took a tiny break here anyway. And we're going to give you 4 questions today. All right, so this question is on being imitated. So being subtly imitated in a smooth, delayed manner would likely A, make you angry, B, make you like the imitator more, C, make you like the item the imitator is trying to sell you a little more, or D, both B and C. Remember, this is being subtly imitated in a smooth and delayed manner. So maybe what that should imply, you don't know this for the question, is that it's an inconspicuous, it's not a blatant instance of being imitated. Okay, hopefully you'll remember that from your notes. All right, I'll give you another 10 seconds. Okay. Well, guess what? You ace this one. It is B and C. Again, we're talking about this inconspicuous imitation. It's not like the type of imitation your little brother and sister used to do on you, which there's no question is angering. Without it being conspicuous, with being subtle, it would make you like the imitator more, and it would make you like the item the imitator is trying to sell you a little bit more. So we talked about the instances of giving away samples at Costco or something like that. If they are doing a tiny bit of imitation, it turns out chances are you like it a little bit more. It was done, I think originally that study was done with a soda or something like that at a store. But yeah, it did seem to work to some degree, and it is something that is sometimes taught to folks who are providing samples. So the correct answer is D, both B and C. That's a cinchy one. Good. We'll do one more practice question before the class is over today. Let's go back and continue talking about this. Right. So the big take home here, and this is I think a take home not just for speech. I mean, I think this is now kind of panning out for other types of perception as well. That the brain is not really kind of looking at specific senses when it's trying to figure out what's going on in the world. It is very flexible and is willing to get any type of information, even if it's never used that channel before. It's willing to get any type of information for speech articulation. Okay. So now we're going to shift gears a little bit here and talk not about speech perception, but talk about voices. And I'm going to talk about the idea that voices and faces do match. And you did talk a tiny bit about this with regard to attractiveness, multisensory attractiveness. Remember, there was both in the book and Dylan's discussion talked about that it does seem to be, there is some evidence that attractive voices do belong to people with attractive faces. But of course, there's tons of, exceptions to this, but there is that type of information first. But that being said, when I talk about this, I always have people say, I've had the experience of listening to a podcast for years and then finally seeing the face of the person who's the podcaster, and they don't look anything like I expect. Right. And I think we all have that type of experience. And we have other experiences where we are very aware of that face, that somebody's voice doesn't kind of really sound right given their appearance. And that's why Mike Tyson always gets so angry when I talk about this research. He's has that high voice that doesn't really match his face very well. And there's other examples. I don't know if you know who Fran Drescher is, but she was on a show called The Nanny years ago, which I think is coming back. Maybe I heard. She's a stunning, beautiful, beautiful woman, but she's got the most kind of abrasive voice, and that's a natural voice. It's not like it's part of an act. That's really how she sounds. So we are aware of these instances where people's voices don't match their faces. Dude, people look so different from how they sound. Okay, I think they often do. However, when we have that experience, I think sometimes it's because we are not looking at the way they articulate. And I will tell you, there is research that when you actually show somebody articulating silently and play a voice, that people do make these matches at better, at least than chance levels. So we can do this to some degree. And so typically in these sorts of experiments, you hear somebody's voice say a word, dog, and then you see two faces, of the same gender as the voice, articulating a word, maybe dog, maybe a different word, and asked which of those faces matches the voice. And people can do it. They can do it at better than chance levels. Okay. That doesn't mean there aren't these exceptions, and I'm very sensitive to those exceptions. I completely understand. I'm very aware of those exceptions. However, when it really comes down to it, if you can see a person articulate, you do pretty well. And they don't even have to be articulating the same word. It can be a different utterance. It can be different speech material. What I mean by that is, you could hear the word dog and then see two people articulate silently the word cat. So you'd hear dog and see two different people, two different guys, for example. And even though the material is different, between what you heard and what you saw, you can make those matches at better than chance levels. That's kind of what I'm trying to portray here. We've done some of these experiments in our lab with female faces and that sort of thing. And then even if not only is the material different, but you're listening to words from a different language you don't know. Okay, so I don't know Chinese, and if I heard a Chinese word, through a loudspeaker, and then I saw two faces of somebody articulating a different Chinese word, two different faces, I would be able to make that match at better than chance levels. Okay, well, there's lots of ways people might be able to do this. It could be done based on, things like the person's age, right? So we know older voices go with older faces. We know that deeper voices sometimes go with people that are larger. And of course, there's this issue of attractiveness that, there is this evidence that attractive voices come out of attractive faces, which are connected to attractive bodies that smell attractive, right? Dylan told you about that. And the book tells you about that as well. It's interesting research. So maybe we do it all those ways. Maybe that's how we're able to make these matches. And again, we're not perfect. And I am very aware of the exceptions. And Mike Tyson reminds me of that all the time. But overall, we're able to do it at better than chance levels. People do look like their voices when it really comes down to it. But are we doing that based on, the perceived age of the voice and age of the face, the perceived size, the perceived attractiveness? Well, I got news for you. You don't need any of that type of information in the stimuli for it to work, because you can basically isolate the speech information both in what one is seeing and what one is hearing, and get rid of information such as age and size and attractiveness. Okay, it works with isolated speech. So how do you isolate speech? How do you get rid of this information? Let's work with auditory speech first. How do you get rid of information about age and size and attractiveness and other things that might identify somebody, like how raspy their voice is or something like that? You do it using a kind of computer technique called sine wave speech. And what sine wave speech does is it basically removes all that stuff, and it breaks the speech signal into simple sine waves. Okay, and that's how it looks here. Sine waves are just kind of like these pure tones. And this is a set of pure tones that are kind of going to go up and down in ways that will allow you to recognize what's being said, even though it doesn't quite sound like speech. As you'll hear, it sounds much more like R2-D2 or computer sounds or something like that. So let me play some of this for you. Oh my gosh. Oh, I'm gonna cry. These aren't. Hopefully you're able to hear that. You're able to hear that? Good. Let me know if you couldn't, but I'll assume if I don't see anything that you could. That it wasn't gonna play it, but it did. So it sounds like R2-D2, right? It sounds, and some of you were able to get it right. Where were you a year ago is absolutely correct. Thank you for responding. This one's a little harder, I think.
Please say what this word is.
Again. Oops, sorry.
Please say what this word is.
That one's a little harder. The answer is please say what this word is. And what it does, I mean, you can tell it gets rid of everything we might typically use, not only to recognize what's being said, but who the speaker is, right? Could you imagine ever trying to, determine if that's somebody you know or not, right? Well, it turns out you can. You can determine who's speaking by listening to that. We'll talk about that in just a second. Anyway, how else do you kind of reduce a stimulus down to just the speech information, not now with voices, now with faces? Okay, and you might be able to guess. You use our point light speech technique. And basically, you saw that. You saw that with the McGurk effect, where it was just these dots moving against a black background. And yeah, you can, extract visual speech from that. You can actually use that to enhance noisy auditory speech. You can basically use it as lip-read information to help you understand a complicated speech signal or something like that. But you can also identify who's speaking, okay? You can identify your friends by just seeing those points move, okay? And which means that if you can hear who's speaking from those sine wave signals and see who's speaking from those points moving, that you might be able to make these matches from voices to faces using these stimuli. And that's exactly what you can do here. Let me show you this. Actually, I don't have sine wave in this stimulus. It's going to be regular auditory speech, and then you're going to see 2 point light faces articulating, and your job is to tell me which of those point light speakers, the first or the second, is the same person as the voice you heard.
The football game is over.
And here come your 2 point light speakers. Yeah. So, not sure if you're able to do that. People are able to do this at better than chance levels. It was the first person. Not only that, if we had played not the regular auditory speech that you heard, but a sine wave version of that, you'd be able to do that too. So you can do it without determining age and size and attractiveness and all that sort of stuff. It seems that your ability, or at least part of your ability to match voices to faces, comes from somehow listening or seeing a person's style of articulation. Because that's really all that's in there, is their articulatory style. We all speak a little differently, right? How we string together our vowels and consonants are all a little different, right? But the way we do it helps people identify who we are and helps that identification, whether you're seeing somebody or hearing somebody. So that's what we're talking about here, idiosyncratic articulatory style. So in other words, when you're listening to my voice, you are identifying it based on, you know, the pitch, the perceived age, maybe the perceived size of my body, the attractiveness, which is the most overwhelming, I'm sure, right? But also you're able to recognize my voice by the way I'm kind of stringing together my vowels and consonants, which is kind of specific to me. It's idiosyncratic to me. And that's what that sine wave speech can capture, that articulatory style. Okay? But that idiosyncratic way I'm speaking, the idiosyncratic way I'm kind of stringing together my vowels and consonants, not only is it available through the sine wave speech, it's available through the point light speech. And that is how people are able to make these matches by listening to sine wave speech and seeing two point light faces and determine which is the same speaker as the sine wave speech they've heard. Imagine being these experiments. These are crazy experiments, right? Because people are thinking, I've never heard speech like this. I've never seen faces like this. And they don't think they can do it. They don't think, I have no idea how I'm making matches. You know, these don't even seem like speech to me. But they guess, and they guess right a lot of the time, which is really interesting. So it's as if the brain is after, your speech brain is not, part of what it's after when it comes to recognizing who a talker is, whether it's hearing a talker or seeing a talker, is going after that particular person's articulatory style, their way that they kind of specifically, idiosyncratically, that's what I mean by this, they specifically string together their vowels into consonants into vowels. We all do that a little bit differently. It depends somewhat on what part of the country we're from, whether we're from the valley or whatever. That's part of what does it. That's part of what determines our articulatory style. But also just our normal kind of physiology also has a influence on how our articulatory style works. The important point is, though, is that information, our articulatory style, is information that can be heard or seen as we experience somebody articulating. And it allows us to make matches based on that sort of thing. Cool. I mean, it's a crazy experiment. I know it's one of the strangest things we've ever done in the laboratory. And like many of our experiments, subjects never think they're able to do it and think we're crazy, and often think that we're trying to test something Freudian or something like that. We have to convince them that's not the case. Okay, let's now continue with this type of idea and discuss another thing that probably the strangest thing we've ever found in our laboratory. And that's the idea that your experience with a talker can be shared across your sensory modalities. And here's what I mean by this. There is a lot of research to suggest that you're better at recognizing the speech of somebody whose speech you've heard a lot. Hey, this isn't maybe that surprising. You know, you're better on a cell phone with people you know, right? When you're talking to a stranger, when you're talking to somebody in office that you've never talked to before, you know, if there's a problem with the cell phone connection, you might not handle it as well. I mean, it might be more difficult to have a productive conversation than if you're talking to your significant other, your family members, your best friend, whatever, right? We actually are better at understanding speech from people we have familiarity with. Not surprising. However, this can be demonstrated in a laboratory experiment where you come in and listen to somebody speak for an hour, right? And then hear a bunch of speakers whose voices are now kind of hidden by noise, not hidden, but are kind of distorted by noise. Noises like this. So you hear that, and you hear somebody behind that, the football game is over, something like that, right? And so it's a typical, the noise is loud. I know I made that speech very conspicuous, but it's hard to hear the speech in these experiments. Just by having an hour experience to a specific talker, you're now able to understand that particular talker's voice in noise better than talkers you hadn't experienced. So this experience comes pretty quickly, and it probably can get it even in half an hour. So we hear speech better from talkers we have some experience. Not only true of auditory speech, but also true of visual speech or lip reading, right? So in other words, again, we bring subjects in, they can't, we ask them, we tell them where they're going to be lip reading. They say, I'm not very good at this type of thing. I say, we know, no one's really very good unless, you're deaf and you have some experience. No one's great at lip reading, but do your best. The sentences are pretty easy. They're all of the form, the football game is over, the ball is on the table, that sort of stuff. People get maybe 1.5 out of the 3 critical words in each sentence, right? But enough that we can kind of measure to see if there's differences. If in fact you do lip read from one person for an hour, again, you're not great at it, but you're just watching this silent face. If you read, you're lip reading, then when it comes to lip reading either that person or a different person you haven't seen, you do better with the person you have some experience with. And by the way, lip readers like Sue Thomas will absolutely tell you this is the case, that she's great at lip reading, but she notices difference. She's always better with people she's familiar with. And what should be important here too, just, when I gave you the cell phone example, part of the reason you're better on the cell phone with your family members and friends and significant others is because, you're more flexible and you can stop sentences mid through or something like that. If you're distracted by something, you're more casual. You also know the sort of things they're going to talk about. But again, even in a laboratory setting where everything else is really tightly controlled, you listen to 100 sentences from one speaker, you're then able to understand them better than other speakers when their speech is in noise. You lip read 100 sentences from one speaker, you're now able to better lip read from them than you are other people. Everything else kind of kept the same, all right? However, we thought in our experiment, the experiment I'm about to talk about, was that if people are learning something about the articulatory style of the speakers they're getting familiar with, articulatory style might be helping them understand speech better. That'd be cool, right? That makes sense. And that might happen both auditorily and visually. Cool, that makes sense. Here's the big one though. If their experience is an experience with articulatory style, then their experience with articulatory style from listening, okay, might help them lip read from that person better, and vice versa. If they lip read from somebody for an hour and then hear that person's speech say different things versus a new speaker, they should be better. If in fact what they're becoming familiar with is something more general, something not tied to a specific sensory modality. And that's what we found. This experience, in fact, can be shared. So we had people come in, and again, these are normal, hearing, normal sighted folks from intro psychology. They come in, we say, okay, we're going to ask you to do some kind of crazy stuff today, but the first thing we want you to do is we want you to lip read for an hour. Do your best, just do your best. Watch this face. They just saw the bottom half of the face. Tell us what you think they hear. And again, they're getting maybe 1, maybe 2 out of the 3 critical words that, they're not great at it. They just do your best. It's just an hour. Go ahead, do that. Okay. And then that part of the experiment's over. And then what we do is we play them speech in noise, sentences like the ones they just heard, but not the same sentences, spoken by 2 different talkers. Okay. This is also challenging. It's not as challenging as lip reading because now they're trying to listen to speech, but it's against that background noise. And what you find is that one of those, by the way, one of those heard speakers is the same person as the person they just lip read. And what you find is that subjects are better at hearing the person, at understanding through sound the person they just lip read from. In other words, your lip reading experiments is then shared with your auditory perception, which is actually really surprising. It works the other way as well. If you first are exposed to somebody's auditory speech, and then you kind of turn off the sound and you see either that person or a new person and are asked to lip read them, you do better at lip reading from the persons whose speech you've heard. Again, it's the same story we've been telling all through this multisensory speech discussion, which is that the speech brain, again, doesn't really care about which sensory modality this information is coming from. It cares about articulation. It cares about what the articulators are doing. It cares about the idiosyncratic way the articulators are creating speech for a specific person, and is then using that experience and is willing to use that experience and take in information from multiple sensory modalities, and it can benefit from that. So what I'm trying to portray here is that the speech brain, at least, doesn't care about sensory modality. It is optimally flexible when it comes to sensory modality. And in some ways, the McGurk effect shows that in some ways it doesn't even know which sense the information is coming from, right? Our experience with the McGurk effect is that your hearing changes in the syllables, even though our ears are always getting the same thing. Our eyes are getting new things, right? It just really wants articulation. It wants information for articulation. This idea of sensory modality, eyes versus ears versus even skin, is really secondary. Our brains are designed for multisensory perception, largely, is what I'm trying to convey here. Okay, cool. I'm going to stop here, and we're going to do our last practice question, and then I'm going to talk a little bit about what's in that final chapter, and we will end there. All right, so stop this and do our final question. And this one's just about good lip readers. It's very straightforward. You should find this very easy, I believe. The question is this: which of the following is instrumental in making someone a good lip reader? So think back to Sue Thomas. A, being deaf. Does that help one be a good lip reader? B, using lip reading as a primary means of communication. C, being female. Or D, all of the above. All right, I'll give you another 15 seconds here or so. Okay, terrific. Most of you got this right. The correct answer is, in fact, D. All of these things made Sue Thomas a good lip reader. And all these things are known to make people, people who are good lip readers, good lip readers. Okay. So being deaf certainly is going to help, right? Because that's going to mean that at least for some individuals, that's going to make lip reading their primary means of communication, besides sign language, which most of them will learn. So both A and B are true. And then there's this, I've not quite fully understood, but certainly consistent finding that female lip readers tend to be better than males. And it's unclear why that's the case, but it is absolutely true. And Sue Thomas obviously is a woman, and she was another great example of a wonderful lip reader. So the correct answer here is D, and you will certainly remember that for your exam this weekend. All right, cool. Let's then go ahead and do our final discussion. And I'm just going to skip around a tiny bit. So if you're looking at the slides that are posted, this is going to be skipping around. So I make sure I address the things that are on the exam. So everything we've just gone through with multisensory speech is really kind of setting up this big discussion of multisensory perception overall. And as I've been hinting, or I've been stating explicitly, I guess, in our discussion, that this is now considered the primary mode of operation. So if you've gone to that chapter and read through, I start off by saying in some ways the entire book is a lie. And what I mean by that is that it is divided by sensory system. We talk about the ears first, and then the nose and the tongue, and then the touch, and then sight. And this is like most perception books are broken down like this. But it's in some ways very, very kind of deceiving to do this, because even though the book and many perception books are broken down like this, I don't think the brain's broken down like this very much at all. I don't think the brain cares very much at all about which sense it's getting the information from. What the brain seems largely designed around now, as we understand it, is multisensory input. And now we believe there are very few areas of the brain that are just dedicated to single senses. And we used to think that there was a visual part of the brain, auditory part of the brain, and they're still kind of referred to like that. But we know, and as well as anybody now, that these areas can take an input from all different senses, and some of that can be just shown through cross-sensory plasticity and when a sense is lost. But other examples show that happens to all of us, and in some ways it might treat the input similarly. I think this is going to go a little beyond our discussion today, but you can read about this, how there are ways of describing light and sound and touch that kind of show commonalities between them, that there are certain patterns across these kind of informational forms that the brain might be sensitive to. Okay, that goes beyond what we'll be discussing today, but if you're interested in that sort of thing, I suggest you read that. Again, this evidence, we've seen this right from the brain's organization. We now know, again, that there seems to be no area that is just dedicated to a single sense. This plasticity we've been talking about throughout development, we do have a sense that it might be the case that young infants don't really experience the senses as separately as we do. That might be something that actually, if anything, we start off completely integrated in terms of our experience, and little by little we can say, oh, this is coming through the eyes and this is coming from the ears. But we're never perfect with that, as you've seen all these different illusions. Which we'll talk about with adult perception. I'm going to skip this next point here, but continue here. So let's talk first about multisensory. So again, nothing new. I'm going to go through this a little quickly. Nothing new, really, but there's early and widespread sensitivity to multisensory information in the brain. And actually, this image now is now too old, but this is showing what we used to think in terms of the multisensory sensitivity of the brain, and this one is showing the more modern perspective. But this is like 6 years old now. We know now there's even a greater number of multisensory areas than we are showing here. Okay, so yeah, sites once thought to be sensory specific or activated by cross-sensory input. You know this. This is just review. I'm kind of just all kind of putting this together, so it makes it easier. We know that your auditory brain is modulated by lip-read information. We just talked about that. We know that hearing can influence visual brain areas. We'll talk about kind of a flashy example of that in just a second, and vice versa. And that you've seen throughout the quarter that touch can influence visual brain areas and vice versa. And even examples of grabbing our keys and that sort of thing. We've talked all about this. Let's see. Let me continue this. I think I skipped here. Yeah, all the cross-sensory. This is all review. We've talked about cross-sensory plasticity again and again. Oh, I'm going to skip this cochlear implant problem thing here too. Don't worry about this. And I'm going to skip this too. I'm going to skip this whole thing here. I'm instead going to show you a couple of little illusions I think that you'll find interesting. This is now showing how much influence the senses have on each other. And I'm hoping these demonstrations work okay. One of the classic examples of this is something called the ventriloquist effect. And this happens with us all the time, which is our experience of the location of a sound is dependent on what we're seeing at the same time. Does this sound familiar? So you might know in movie theaters, usually in movie theaters, sound is actually coming from the side, but you experience the sound coming from the screen, the action on the screen, even though you hear, your ears are getting speech sounds from the side, you experience the speech coming from the face of the actor on the screen. And so it's a ventriloquist effect in that it's kind of drawing the information, the sound information, to where you see the sound coming from. Okay, very well known effects. Here's a couple of other effects where, and this is kind of fun just to talk about illusions. This is an instance where what you see will depend on what you hear. So you're going to hear something, hopefully clearly here, and see something. And my question is going to be is how many, when you see it's going to be a dot flashing, how many dots do you see flashing here? Did you see a dot? I didn't even see it. Wait, let's make sure it's working. Yeah, there it is. Okay, I see one dot flashing there. Again. Okay, and how about here? How many dots do you see? I hope it's synchronous enough for you folks. Shoot, hold on. Okay, that's working for me. Might not be working for you because of the synchrony problem. So I see two dots flashing there. However, in both cases, it's kind of like a reverse McGurk effect. In both cases, it's just a single dot flashing, but the number of flashes I see is being influenced by the beeps I'm hearing. Okay. Here's another example of this. Oops. Where is this? Shoot. Ah, no, I don't have that. Okay. You know what I'm going to do? Let's see what time it is. Okay. Let's just finish up. I do read the chapter. I'll try to emphasize what we've just gone through, and I've had so much fun, so many fun things to show you here, but I'm not going to have time. Let's just do the last slide. The big kind of summary here, and this is just what you saw in the very beginning. You're perceiving more than you realize, as we've learned throughout the course. A lot of this is below the level of consciousness. It's what we're calling implicit perception. These skills can be enhanced as we learned as we went through the quarter. right? They can be enhanced with experience, whether it's experience related to a sensory loss, experience related to a profession, or explicit experience like the wine connoisseurs, right? And the nice thing is all this demonstrates this plasticity we've been talking about throughout the quarter. Many of these skills show that we can use channels of information that we didn't think were relevant to that type of thing. You can hear space, you can now, see speech, you can recognize other people through touching them and through smelling them to some degree. And all of this, again, demonstrates this primacy of multisensory perception. And then finally, one thing that we are most sensitive to are human actions, what other people are doing. And now we know that some of that sensitivity comes from this kind of internal imitation that we were doing with them. So that's a big conclusion slide. Just want to make sure I put that in there. Thanks. Hope you had fun, and good luck on your test. I'm available over the next few days if you want to ask me any questions or anything like that. But otherwise, good luck on the test, and I will hopefully see you in the fall, maybe, if you're around. It'd be nice to meet you in person. You can stop by my office, assuming we're back on campus. Okay, enjoy the rest of your summer.